Hi, in this video we're going to see a pretty good review problem that kind of ties in a lot of stuff that you've learned in a course on business calculus. I call it the marginal revenue, marginal cost review problem, and this is a type of problem where you're given functional forms for your marginal revenue and marginal cost, and then you're asked a bunch of different questions, usually related to the profit function. Okay? So let's say that our marginal quantities are both given in dollars per item, and the marginal revenue is $2,400, and the marginal cost is 60 times square root of x plus 4, and the fixed cost is also equal to $600. Forgot about that part. Okay, so this is all the information we're given, the two marginal quantities plus the fixed cost amount, and I claim that with this much information I can answer all of these following questions. What's the total profit function? What value of x will maximize my profit? What's the maximum total profit? Boy, that's a lot of questions. Do you know how to answer these questions? Now, before we begin, I would invite you to try to write on your page ABC, what do you think? Just write down your thoughts. Nobody's watching you right now. I'm not going to see what you write down. Where would you go with A? Just don't do the math, but just write, what's the total profit function? What's my strategy here? What are the steps that I need to do in order to figure this out? Same thing for B, same thing for C. Kind of just pause the video and jot it down and then see if your ideas line up with the solution that you see next. Did you do it? I hope so. Okay, now here's my claim. One of these questions I can answer right away without even doing any integration at all. Now, I bet if you just did practice writing down your strategies, you probably use the word integral or the idea that you have to integrate something, right? Sure, I'll get to that. But I do claim that one of these questions, A, B, or C, could be answered with no integrals at all. I want to do that first. Which one is it? B. What value of x maximizes profit? Now, when you were writing down your strategies, did you think that you had to find the total profit function first and then follow along with the plan for optimization to find that? Well, what does that plan entail? First, you take a function and then you take its derivative, set the derivative equal to 0, ... all that other stuff. So guess what? We already have the derivatives right here. Remember? Because profit is equal to revenue minus cost. So if I take the derivative of this entire equation, it tells me that marginal profit, which is the same thing as pre-prime, is equal to R prime minus C prime, which is my marginal revenue minus my marginal cost. Right? So that I claim that I can answer part B without doing any integrals because my general strategy for maximization, optimization, is to take the derivative and set it equal to 0, and I already have the derivatives right here. And funny thing is, if I set the derivative of profit equal to 0, which is what I do if I'm looking for max P, I would take the derivative of P and set it equal to 0. That just tells me that this right here is equal to 0, right? And that actually, if you move MC to the other side, just tells me that MR equals MC. Does that sound familiar? We actually went over this a while ago in the section on optimization. When you're looking for your optimal profit, it turns out that that's located at X values where marginal revenue equals marginal cost. And it's because of this reason right over there. Okay, so that's why I think part B is actually the easiest on this list. So I'm going to go ahead and do part B before I do parts A and C. Okay, what value of X maximizes profit? That's going to be any relative max that I find out of the solving of MR equals MC, or 24,000 is equal to 60 square root of X plus 4. Okay, hold on. By the way, if I say MR equals 2,400, not 24,000, 2,400, what does that mean? What price am I selling my items for? How much each? $2,400 each, exactly. When you see that your marginal revenue is constant, then that is actually equivalent to your fixed price. So here, the price of my product must be a pretty nice product because it costs $2,400 for just one of these. Okay? All right, on with the problem. We're just going to solve this out for X. Oh, this is going to be a review of your algebra skills. Why don't you go ahead and just do this? Don't just watch me do it. Pause the video. X equals what? Did you do it? I hope so. What did you get? 1596? That's what I got. Yes, you got it. Okay, so let's see how it goes. We're going to divide by 60, divide by 60, and so you get 4t right here is equal to the square root of x plus 4. Hopefully you didn't get stuck at this stage, but if you did, I've seen that before. This is where most people get stuck, right here. What did you do? How do you get rid of that pesky square root sign? You got to square it away. Exactly. You got to square both sides of the equation, and so then squared out that 1600, and then that went away. Subtracting 4 from both sides, you get 1596. Right. Okay. What does that say? Does that say that for sure this is just the place where I got my max profit? I just box this and be done with it? Not yet. Hold on there. The other thing that I'd like you to do is show that this classifies. Remember that this is just a critical point. At this point, this is just a critical point. Is it a min? Is it a max? We haven't answered that question yet. So we have to actually classify this using the f prime number line. Or in this case, it's going to be the p prime sign number line. Haven't heard that in a while. That's why this is a review problem. Okay, so I hope that this is a max. I have a feeling it's going to be a max, but I need to prove that it's a max by saying that the derivative of p is equal to 0 right here. And when x is less than that, is p prime positive or negative? How am I supposed to find that out? Oh yeah, because p prime is mr minus mc, and you have equations for mr and mc right here. Right, so you can just plug in a test point. Like let's say you want to test, maybe you're going to test the point x equals 0 because that's less than 1596. Alright, well p prime is 2400 minus 60 times the square root of 4. So the square root of 4 is 2, so that's 120. That's a positive number. And that means these are all positive numbers. That means that profit is increasing until I hit this horizontal tangent. And then what happens? Well, you can just take another test point. If you want maybe x is equal to, oh, I don't know, 10,000, just some number that's bigger than the number that you have for your critical point. And you're going to see that 2400 minus 60 times like the square root of that huge number comes out negative, okay? So with my p prime sign number line, I go from increasing to a 0 tangent to decreasing, and sure enough, that's a max. And so now I've proven that that critical point is a max. And that was the easiest stage of this question. How are you feeling? Is that right? Okay, so what value of x maximizes profit? Scratch work here. The answer is x is equal to 1596 items. And then I'm going to go on and try to answer A and C. Now, I just got B, right? So can I just skip ahead to C? I have the x value right here. Could I answer C real quick? What's the maximum total profit? No. Because the answer to C, if you remember from optimization, would require that I take the x value that I got in B and plug it into the profit formula. Dang it, that was part A. What is the total profit function? P of x equals what? So I need to be able to answer that. What is the total profit function? And then the answer to C will be P of 1596, and whatever that is when I plug in 1596. But isn't it funny how we were able to get this without doing the integration that yields the total profit function? Ha ha, yes, hilarious. Okay, so let's get that total profit function. Profit is revenue minus cost. So really, the underlying question is, what's the total revenue? What's the total cost? And then what's the difference between those? And that'll get me my answer for part A. Okay, so in part A, I need to find my total revenue, which is called R of X. And I have to find my total cost C of X. Each one of those is an integration initial value problem. And then down at the bottom, my profit function is my total revenue minus my total cost, and that'll get me the answer to A. Alright, why don't you try this part 2 by yourself, you know, see how it goes, make sure you've got plenty of practice in so you're able to perform on any possible exams you might have to take. Okay, do it? Revenue's the easier one, isn't it? Yeah, that one's a little easier because marginal revenue is just a constant, 2400. So total revenue is the integral of just that constant dx, and that turns straight away into 2400x plus c, and c is not always 0, but in this case, because r of 0 turns out to be 2400 times 0 plus c, in this case, c turns out to be 0. Right. So my actual total revenue function right here is c is equal to 0, 2400x. And if you like to see total revenue as the product of price times number of items, then again you can see that 2400 is the selling price of my awesome, fabulous product. Okay, hopefully that one was straightforward for you because the cost one is a little harder. It's got that square root in it, right? So we're going to have to deal with that. The cost is going to be the integral of 60 root x plus 4 dx. One thing I can do to help myself out immediately is pull out the 60. But then I have square root of x plus 4, or maybe you would prefer to see it for this as x plus 4 to the 1/2, right? Man, if that was x to the 1/2, I would know what to do with it right away. But it's not, it's x plus 4. So what do you think we're going to have to do? A little u substitution, right? So we're going to let u equal x plus 4, and that way the du is equivalent, equal to the dx. And this becomes the integral, don't forget to bring the 60 down, of u to the 1/2 du. And I know what to do with that, right? Because if I had x to the 1/2, same thing if I have u to the 1/2, I'm just going to add 1 to that power. So I get u to the 3/2, and don't forget to divide out by exactly what the new power was so that it would cancel if you took the derivative. And then I'm going to switch that around a little bit. The 2 comes up front, the 3 is still divided by. 60 divided by 3, that's 20, times 2, that's 40. So it's 40, and then the u was x plus 4 to the 3/2 plus c. Oh boy, I'm not going to have enough board space to finish this one off. Okay, so anyway, we have our revenue function, so let me just write that as something that we've already found. The revenue function is 2400x. And we are working on our cost function. You see that was a little bit harder than revenue. I've got to this point. I haven't solved for the plus c yet, and please do not confuse the plus c with the capital C, which is also used, unfortunately, for total cost. That's just an unfortunate coincidence. These are totally different conceptual variables. If you want to not confuse yourself, you could call that K. You could, C stands for constant, but you could use A, B, C. You could use any letter you want that's not already being used, and maybe that'll help to relieve the confusion, okay? So you just plus a number. And this letter is the placeholder for the number. Okay, so I'm going to use K to not confuse it with C and say now that I'm going to solve for K. Well, I need an initial value to solve this initial value problem, right? So what initial value do I have? It says fixed cost equals 600. That's the only thing I haven't used yet that was given to me in the problem. Maybe now's the time to take advantage of that, right? What is fixed cost? That's how much it costs even if you don't make anything, right? So that's C of 0. And so if we take 0 and plug it in for x, we get 40 times 4 to the 3/2. So I just did 0 plus 4 right there to get 4. And then there's my constant of integration, which I'm calling K just for this problem. And that's supposed to be equal to 600. And so K turns out to be equal to 600 minus 40 times 4 to the 3/2. This is actually equal to 8 because the square root of 4 is 2 and that cubed is 8. But if you wanted to use a calculator just to make sure you don't mess this up, you should get K is equal to 280. Okay? So K is equal to 280. So in conclusion, I could actually say that R of x is equal to that, and C of x is equal to 40 times x plus 4 to the 3/2 plus 280. Whew. So far so good? This sounds like kind of a good problem for like, I don't know, a final exam at this point because there's so many concepts inside of a problem like this. Wait, okay. Anyway, let's get on with this and what's the total profit function? Let's finish it off there. Okay, what's the total profit function? Let's see, profit is equal to revenue minus cost. So that's 2400x minus, don't forget to put your cost inside of a parentheses because otherwise you run the risk of adding 280 instead of subtracting it. Okay, so don't forget about that right there. And then that's your final answer for part A. What is your total profit function? Whew. Now we can answer part C. And remember, we already did part B without having to go through all that stuff. That's why I wanted to do it first, to just show you how cool it is that you can get straight to the heart of the matter of maximization without even having to do the integral part. But you can find out how much your actual total profit's going to be without having gone through all that integral mess. So we can finally answer part C, what's the maximum total profit, by taking the number 1596 from B and plugging it into this function right here, and you're going to get 1270120. Ooh, that's a lot of money, like 1.3 million bucks. Well, they cost 2,400 each. They're very fancy things. Now wait, before I box that, it says, what's my maximum total profit? They didn't say relative max. They didn't say absolute max. But what do you think they meant when they said, what's my maximum? They probably meant absolute max, right? The absolute maximum that it could be. So before I go ahead and box that answer, I want to make sure that this relative max that I located is in fact the absolute maximum of the function. Okay, and the easiest way to do that is just to confirm with a graph. So you want to pull out your graphing calculator and just graph the function p of x, and you're going to see it kind of looks like a parabola, but notice by its functional form that it's not a parabolic equation, it's not a quadratic equation. So it looks like a parabola, but it isn't one exactly. And then this graph is great because it can also confirm for you the analysis that you did. You should see the peak right at 1596, and you should also see the overall global behavior of the function going up, hitting its relative max, and then going down for the rest of x. And so that means that not only is this a relative max, but this is also my absolute max, which is what I think they were implying when they said, what's the maximum? And so now I can confidently put the units of dollars on there and then just box that answer